Okay, let's go ahead and get started there, everybody. Welcome back to another Unreal Engine study session. I'm your host, Strange Bear Jim, and today we're going to continue where we last left off with the Unreal Engine study session. We're continuing our progress through the full audio section, learning what we can. Obviously, Blackheart and I are not sound engineers, so we're going to be having a little bit of difficulty from time to time on that. Um, we're asking people to go ahead and, speak up in our comment section on the videos that we upload. Um, maybe we can get a little bit more clarity on some of the topics of the, from actual sound engineers. Get a little bit more clarity on along those lines. Um, so that we can then take that and, use that for our, um, the clone that we will eventually make, and then, use what we've learned, through it all and take it onto like making, additional, 2D games later. Um, Last we left off, we were in the audio engine overview. We got through like basically about another 1/3 of the entire content. So we're pretty much on the last third of the content there, trying to figure out, everything about this. You can follow along on the 4.27 documentation on the Unreal Engine if you're so inclined. Um, so hopefully that's something that might interest you. But yeah, I see that Blackheart is in the stage now, so let's go ahead and invite him over. There we go. How's it going there, bud?
Doing A-okay.
Awesome, awesome. Okay, so I'm going to go ahead and get this live here. There we go. All right. So let's see. If I remember correctly, we finished off the direct volume adjustments last time around. So we were going on to the sound classes, I believe.
Yes, I believe so.
Okay. Now, was there anything, have you gotten any, like, anybody, like, speaking up on your videos or anything along those lines? Maybe getting,
Not yet, no.
okay. I was just kind of curious if anybody had spoken up yet about anything that we've previously talked about, you know, so that we can maybe address that, like, right then and there. Um, But yeah, no comments on mine so far, but that's okay. You know, they'll come, or at least I hope. I hope they will. So okay. So shall we get into this?
Yeah.
Okay. So sound classes. A sound class is an asset that provides a bucket of common settings for assets that share some semantic meaning. One primary motivation for grouping sounds together into a common classification is to control volumes of sounds as a group. Sound classes are created and modified in a separate sound class graph editor. In addition to volume, sound classes, okay, can be used to control other parameters and sounds in a class group. Okay. Not quite sure what sound classes are, but you know, unless they just
Maybe
accidentally,
typo, maybe?
maybe that's the only thing that I can think of. But I mean, this is like the second time that we've seen sound, so I don't know.
Don't know.
Yeah, so
Feels somewhat like a typo.
seems that way to me as well, but I don't know. Um, all right. Everything in there seems fairly straightforward for the most part, so
Mm.
so we'll move on. Unless there's something that you need as always, if there's something that you want to talk about or just, feel free to speak up.
Yeah.
So, a sound mix is an asset type that applies dynamic sound class volume and pitch adjusters to sound classes. Sound mixes are the traditional method with games to perform class-based volume control, include ducking. Okay, include ducking. Huh? uh, what? Uh, Volume ducking is achieved during a passive mix modifier, a mechanism that indirectly applies a mix when a sound plays on a given sound class. In this way, a game can, for example, cause ducking on background ambience when a player talks or when a gun shoots. Um, that doesn't. Um, Maybe I'm missing something, but it doesn't feel like they're really addressing what ducking is.
Might be like temporarily lowering the volume or something.
I mean, they say volume ducking is achieved using a passive mix modifier. Um, so
Like, it
cause
sounds like it would be something that would done automatically without you having to intervene in any way.
maybe cause ducking on background ambience when a player talks or when a gun shoots. It's like, okay, maybe you know, not quite sure exactly. Not quite 100% sure I know what ducking is like referring to. Now I don't know if
Like the
that's like
best example I can think of is I don't remember exactly the game, but there was a game whenever characters started talking, all the ambient music and background music was just lower its volume automatically so you could hear the conversation and not get muffled by everything else.
I mean I guess
I'm
that
guessing that's what it's referring to docking.
yeah. Um, you know, it's the clearest. It's a um, is the and what you just described is probably the clearest that could be that. I mean, it makes the most sense, at least to me.
Yeah.
So I'll take that one. You know.
Yeah, that's what it
Um,
feels like it's describing, at least to me. That's what it feels like, what it's describing.
yeah. Um, but they probably could do a little bit more on trying to describe exactly what decking is all about. It feels like. But I don't know. But yeah, it feels like what you just stated. It does feel like that would be like the correct interpretation. So,
Mm.
all right. Moving on. Yes.
Yes.
All right. Sound parameter modulation. A newer mixing method to control a game mix is with the audio parameter modulation plugin. This plugin generalizes the concept of changing audio parameters through a mix. Sounds can now associate their parameters as modulation destinations of a parameter bus. A parameter bus is an object that allows arbitrary parameter modulation sources to write into the bus. For example, a modulation source could be from a blueprint, derived from a parameter mix, or from some interactive system, or from a parameter modulation oscillator such as an LFO. Wait, wasn't LFO? What was that? That was the low frequency.
Yes. I think it was a low frequency output, was it? I mean, go back up and see again.
I was thinking low pass filter, but that's not it.
Could be. No, low
No,
filter is not.
that doesn't fit. And that's not the right kind of acronym. So,
Uh,
hmm, well, let me do a quick search on it. Nope, that's the only one on this page.
we might have seen it on a different page.
Maybe. Uh, Instead of controlling only the volume parameter of a sound, the parameter modulation plugin also generalizes the concept of parameter modulation. It allows the same um, paradigm, I think that's how you pronounce that, to control any number of output parameters, such as filter frequency cutoff and pitch modulation. I think that's paradigm. Hold on. Let me. Okay, well, I didn't really want to copy that word, huh? Okay, come on, copy. Yeah,
Paradigm.
yeah, paradigm.
Yeah, I think it was, yes, paradigm.
Okay. Um, to be honest, I kind of read through that. I blurred through it, unfortunately. Um, hmm. I mean, I
I
get.
guess it's saying it's controlling multiple audios at once.
Well, I mean, I get what like a parameter bus is all about. When you look at, you know, um, any kind of computer, when you look at the bus of a PC, for example, you typically, um, you're trying to limit what information is sent to the CPU, so that you can kind of, so the CPU can handle everything that's coming at it and, process everything that needs to be handled, right? So you throw it onto a bus in a particular order so that CPU can handle it and it gets outputted. Obviously, they've been trying to figure out how to get around that bottleneck for years now, given the current architecture of hardware. But I personally don't know if they've gotten past that yet or not. Um, I mean, you can try to do what you can with multi-threading, but let's face it, the CPU can only do so much, and at the same time, it also has to be careful that, because multi-threading could, have, you know, consequences, you know, like one thing might get like added or multiplied first, when in fact it should be having like another digits, yeah, that are multiplied or added first, that kind of thing. So,
Mm-hmm.
um, hence the reason why that bus is there to kind of limit, what it does, so that it, does everything in the proper order. They're trying to do that with the multi-threading, but obviously, that doesn't cover it completely, right?
Right.
Um, Now, if I apply that to sound or this parameter bus, feels like a good, um, it feels like that's similar, right? You have all these sources being written into the bus that it can be then, handled. Um, but, I'm not sure if that's exactly
I
what,
think that does sound pretty accurate to what this is doing.
yeah. Um, so As for modulation destinations and, you know, parameters in general, I'm not quite sure exactly what everything that they're kind of talking about is per se on that. Um, I mean, when you think parameter, you think of like something like like maybe a variable, something that can store value to it typically. I don't know if
Yeah,
that's true or not, or if that's a right comparison in this case, but um,
I think that would still apply. You can measure frequency and you can measure pitch with a number.
yeah,
So maybe that's what it's doing.
maybe. So I don't know. I feel it's this particular section. It feels like we're like like so close to what it actually is. Um, Although we've already covered the audio modulation overview, so
Yeah.
yeah. But it does feel like we were given like a little bit extra information here with the whole parameter bus, but I don't know.
Yeah.
Um, all right, shall we move on?
Yeah.
Okay. Okay, because concurrency management. So, an often overlooked aspect of game mixing is to issue a managing sound concurrency. Essentially, how many sounds of a given type can play at the same time. Without careful management, it is easy for games to generate a flood of sounds of one type, such as guns and other enemy weapons. I mean, that's true.
Yeah.
Um, if you have like thousands of like you know AI drones that are on the battlefield and stuff like that, and they're all firing their guns all at the same time, then that sound can just overwhelm overall, right? So
Yeah.
that makes sense. So um, the Unreal Audio Engine provides tools for sound designers to control their concurrency groups via the sound concurrency asset. This asset defines the limit of how many sounds to allow in the group and what to do once that limit is reached. Okay. Um, so obviously, if we are going to be dealing with um, a game that has like hundreds of enemies or something along those lines, trying to that have their own sound files to them, like say, we create a game that is dealing with like the zombie apocalypse, right? And now
Yeah.
you have like hundreds of zombies that are out there going, ugh, brains for each and every single last one of them. It's gonna get messy when you hear, yeah, all the time, right?
Yeah.
Your ears are gonna burst. So obviously, having something like that can basically go, okay, instead of 100 zombies saying all that, maybe we'll just do like 10 or something,
Yeah.
that kind of
You
thing.
could pretty much use Warframe as an example. Whenever there's like a full 4 team, there can be like so many mobs in at once, but you don't hear that many now, do we?
Hmm. Well, I mean, you typically only hear like the ones that are like typically like right next to you for the most part.
I've had
Um,
moments where I had like a lot of them right on me, and I wasn't being overwhelmed by audio.
all right.
So that would be a good
Mm,
example. Like there's so many on you, but you only hear like some of them.
yeah. But then again, some of them aren't necessarily doing like sounds like all the time either. So when it comes
Yeah,
to
that's one way of limiting it. Like,
yeah, when it comes
oh,
to Warframe,
this kind of stuff.
it's not like
Yeah,
a
there's like,
continuous sound for them. So
well, even when they shoot, you only hear some of them shooting. Like you don't hear all of them going to town with all their guns at you,
mm,
and you can't be shot from multiple of them at once.
yeah, I guess. I don't know. I think I think I still kind of hear it, but obviously, they don't. They're not firing off their weapons all the time. They're not. There's not like hundreds like next to you shooting you. So it doesn't seem like that. Um, that would be um a I don't know. I get what you're saying, but at the same time, I think they are. Hmm, I don't know. I think they still play the audio, even though technically we're not dealing with as much there. I don't know. Um, I guess one game that I could think of that, never like overloaded you too much with sounds is like an old um an old game, Plants vs Zombies.
Oh yeah,
When they have the wave come in and you have all those zombies like, you know, um, popping in, all you hear it is like, one, zombie going, brains, kind of thing, and that's it. You're not hearing like
yeah,
every single last one of them going, oh, brains, because that would probably be a little too much. So,
yeah,
so I think that's, obviously, Plants vs Zombies isn't necessarily running, Unreal Engine, but still, I think that is a kind of a good example for it, I guess you might say. You know, where it's just basically them saying, "Hey, we're using way too many sounds at this particular time. Let's use the sound concurrency to limit, how much we're hearing." And obviously you can kind of do a little bit more other than sound concurrency, such as like um, you you limit how many enemies are like on in the area. You know, you could do something along those lines. You can basically say that one particular voice um, has the primary, and then maybe a secondary voice elsewhere, but that's about it. Who knows? Um,
yeah,
I'm sure that there's ways that you can do, that can get around the sound concurrency. Like just volume itself, like ambient volume, like, hey, this is kind of outside my ambient area, so I'm not hearing it or something.
yeah.
Who knows? But
Probably another game I can think of that probably does something like this is Dynasty Warriors.
okay.
If I don't know if you ever seen anything of that game, but there can be so many troops going
Mhm.
at you at once, and it's purely melee combat,
Right.
and you're just mowing them down.
Right.
But the game doesn't overwhelm you with audio.
Right. I
And
mean,
I'm not talking like maybe 50 or 60. No, I'm talking like hundreds of enemy units coming at you.
right. And you're not necessarily hearing every single last unit, basically,
No,
giving
there's a
like
limit
a
of how many of them you can actually hear.
right. So yeah. So I mean, again, it and we can definitely see examples of when you would want to try to consider using it, but at the same time, there might be other ways that you can um, you know try to get it, try to do the exact same thing, but in other ways, you know.
Yeah.
So, but yeah. All right. So, for example, a sound designer could choose to stop the oldest sound when a new sound comes in, or alternatively, to reject new sounds and continue the ones that are already playing. Sound concurrency also allows groups to happen in a chain, where a hierarchy of concurrency resolution needs to pass for a sound to play. For example, footsteps might exist in a concurrency, limiting the total number of footsteps, but that, in turn, could exist in a concurrency group of Foley sounds, and again, in turn, might be in a concurrency group of sound effect sounds, and so on. For more information, see Make Sound Concurrency Setting. So, all right. Fairly straightforward, I would imagine.
Yeah.
So, um, all right. Next one. Global. Um,
Polyphony. What is it? Polyphony.
I'm not quite sure how to pronounce that. Hold on one second.
Polyphony management.
Polyphony.
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 Yeah.
I was getting close then.
Yeah. Yeah. I was thinking, I was thinking to myself like, polyphony, and it's like, no, polyphony. You know, it's like, okay. Managing the number of sounds that can play at once in a game is called polyphony management or voice management. The primary cost of an audio engine is decoding and rendering sound sources, so that one of the primary tools for reducing CPU cost is limiting the number of sounds that can play at the same time. Makes sense. In Unreal Engine 4, this number is set in a project setting that you can change based on target platform. The number can also be changed dynamically while the game is running, so in situations where performance is bottlenecked or tight, the audio engine can dynamically reduce the number of sound sources to be rendered. Once the audio engine reaches the number of sounds it can render, it needs to decide which ones to play and which ones to reject or stop. This is done through a combination of sound volumes total, the final volume of the sound after all stages are accounted for, the sounds and the sound's priority. For more information, see priority. Okay. This is again another one that is like, feels like it's very similar to the sound concurrency. In
Yeah.
that it's like, hey, you have 100 sounds that are trying to play all at the same time, but you really don't want all of them to be playing at the same time. That would be just god awful. So maybe limit that 100 to like say 10 or 5 or even just one. You know, so it doesn't get too overwhelming. So it makes sense. Makes sense. Okay. Any questions so far? Or?
No.
Okay. DPS effects processing and synthesis. The Unreal Audio Engine also features a robust digital signal processing, or DSP, effects processing pipeline. Individual sound sources can identify a digital signal processing, or DSP effect chain to be applied to individual source instances. Settings for these effects can be changed at runtime in Blueprint and will support live previewing changes while the play and editor session runs. While the Pi session runs, huh? Okay, interesting. Something to remember there. Play and editor is equal to pi. Gotcha. Unreal Audio also has a submix graph editor that allows sound designers to apply digital signal processing effects and perform analysis on mixes of sound sources. You can construct submix effects in submix effect chains. Sound sources can be specified to play on any given submix and to send their audio to send effects to any other submix graph. Any sound source can dynamically route their audio to any submix from a blueprint. Further, sound attenuation settings support sending audio to submix effects as a function of distance. There's a huge variety of possibilities. The Unreal Audio Engine is flexible enough to allow canonical master effect setups like master EQ, master compression, and master reverb, while also supporting experimentation and exploration of the custom digital signal processing, graphs, and route schemes. A variety of source and submix effects have been implemented in the synthesis and digital signal processing effects plugin, and new effects are always being added. With our growing digital signal processing C++ library and our signal processing module, it is easy to add new effects via the Unreal Audio Engine's digital signal processing and synthesis C++ API. With other robust tools and technology in Unreal Engine 4 via automatic property reflection and hot loading DLLs, Unreal Audio Engine is an ideal place to learn about writing digital signal processing effects and to serve as a platform for cutting-edge experimentation and research in game audio technology. Oh boy, that was a paragraph or two. um, um, yeah, hmm, I, hmm.
Hmm.
In some ways it's like, oh yeah, this I'm getting all this, but on the other hand, it also feels as though um, there's some details that doesn't feel like it's clicking like completely either. You get what I'm feeling?
Yeah.
You get what
Yeah.
I'm saying on that?
Yeah.
Um, so not sure. Hmm, I don't know. Uh, shall I just move on, or is there something that you might not be processing very well with this section?
Uh, let's move on.
Okay.
I'm kind of in the same position as you on this.
Yeah. Oh yeah. We'll move on. Asset cooking. When cooking for a target platform, like actual literal cooking, uh, assets are compressed into codecs specific to both the platform being targeted and the feature the sound is using. For example, Unreal Engine 4 will automatically encode to hardware accelerated codecs on platforms where that is supported. The U-Wave that wraps the imported asset as a quality slider to help cook time compression schemes in relation to the quality the sound designer is targeting for the given asset. This quality value is interpreted differently based on the specific codecs using a target platform. Um, okay. Um,
I guess it's referring to the limitations of each platform. Like, well, on PC, you can just upgrade your computer to get better performance, and Nintendo Switch would have far lesser performance than the PC would.
yeah, um, I don't know if it's based off of like something broad like, hey, this is meant for PC or hey, this is meant for mobile, or if it's something a little bit more nuanced like, hey, I have an NVIDIA graphics card, or hey, I have a AMD graphics card, or something along those lines, right? Does it go that in depth on um, what the what's being presented, or um, is it you know or does it go broad, like what you were saying with the PC and Switch? You know, not
Yeah, you
sure.
can even compare an Xbox with a Switch, and the Xbox being having superior hardware than the Switch, that's able to perform a little better than the Switch would. Like better, some things would be better quality than it would be in the Switch. It all depends on how those consoles handle the information.
Yeah. Um, but I'm just kind of curious as if that is something that it's being um, if this is what it's being referred to. It's like, hey, you have the Xbox with a certain number, certain graphics card, and then you compare that to PC that, could have a differing graphics card, like it might not have all the,
That's
you
why
know, the
Unreal
right.
4 is saying that it will
So
automatically encode to hardware acceleration codec
yeah,
based on the platform. So yeah,
or is it something that will, you have to actually modify, like in the menu system, like, hey, I'm using this particular hardware, so you have to interpret it this way. I don't know. Or is it something where it's like, hey, I want to make sure that the game runs in this fashion with NVIDIA cards and this other fashion with AMD video cards or something like that. I'm not quite sure. Um, what exactly are they kind of going for there? Is it broad, or is it very specific in the asset
it's
cooking?
broad pretty much. I don't know. There are many games that are made multi-platform and that can pretty much cross-play as well.
Hmm.
That you can take as an example, like Warframe, Genshin Impact. What there was this other game. What was it called? That was also multi-platform and cross-play. I don't remember if Minecraft was like that as well. At least with the Bedrock version.
Well, the Bedrock is their C++ version of Minecraft, so
Yeah, but like
um,
it is multi-platform, but playing it on one thing is not the same as playing on another thing. Like someone you're playing with could be playing on the PlayStation, and while another one is playing on an Xbox, and someone is playing on the Switch, but it's still technically the same game.
right.
But the engine is automatically adjusting the game based on what hardware is detecting.
Yeah, and that's what I'm kind of wondering, is it looking at the hardware itself and saying like, oh, hey, this hardware can only do so much, so therefore we're gonna cook to that level of specifications, or if it's along the lines of, hey, we have um, you know, we just downloaded this application on the PC, so we're just gonna use these PC settings, you know, and the
Pretty
codecs,
much that's what it's feeling.
yeah,
That's pretty much what I feel the engine itself is doing.
yeah, I don't know. I feel like, they could be considering like maybe both in that. Um, like it first like looks at the broad aspect and goes, okay, this guy's using a PC, so we're gonna use these settings first, and then we'll look at their like graphics card and see what that can handle, and we'll interpret that. Um, I don't know if that's something that um, if that is being done or not. So I don't know.
I'm thinking that up to an extent it is in order to determine okay what graphics accelerator does it have, what uh processor is it using,
Yeah. Well, the
what hardware is managing the audio. Like it'll look at that directly the hardware to determine okay, so this is what it has this hardware has access to and I'll let them use this.
yeah. The question that I have is, would the engine itself be handling something that is like, um, like, hey, this computer has this particular graphics card. Is the engine itself trying to handle that? Or do you actually have to code it into the game saying like, hey, for this particular graphics card, we want you to use these particular graphic settings, or something along those lines. I don't know.
I
Um,
think from what we read, like the engine does it itself, but I'm guessing you should be able to override that with code.
yeah. Um, so and that's what I'm kind of wondering about on this one. It feels like it could be automatic, but at the same time, I don't really know. This feels like
It
um,
does feel automatic to me. From what it's explained, the engine does it automatically.
yeah. Well, I mean, it's saying right there, Unreal Engine 4 will automatically encode to hardware accelerated codecs on platforms where that is supported. Um, so, um, but I mean, you know, where exactly are they getting these codecs from? Is it something that
Some kind of
you know,
library, probably.
is something that, Unreal itself has already built and stuff like that? Or is it something that like you and I make for it to interpret?
Mm,
Or is
no, I
it,
think it's taken from an Unreal library.
or could it be something that is provided by the hardware manufacturers themselves? Like, hey, here's you know, we already know the standard, that everybody wants us to have, so here's our current standard or something like that,
I think it was managed by the engine and not the hardware, because after all, hardware's always changing, the engines are always changing, and it will be very hard to stay consistent.
True. But at the same time, um, there is a certain standard in hardware, or in at least in PC hardware. So, um, that they kind of have to go by in a certain, you know, by a certain amount, but still, that doesn't necessarily answer my question. you know, there's various ways to interpret this. So, Alright, well, shall I move on?
Yeah, let's move on.
Alright. Asset compression overrides, automatic quality reduction. Unreal Engine 4 has a wide variety of tools that sound designers and engineers can use to control automatic QuickTime downsampling and quality scale reductions for any given target platform. This allows a project to ship on as wide a variety of platforms as possible and with as little platform-specific content redesign as possible. For example, a project that ships on PC could automatically have the asset memory footprint reduced when targeting a mobile platform. Okay, that's helpful.
Okay.
That's helpful.
Yeah. It is weird that it's on the audio section because I see that more as the more visual stuff than the audio stuff.
Oh, I can totally understand the audio being reduced as well because when you compare PC to mobile, where for PC you could have like an actual honest to gosh surround sound for a PC, whereas with the phone you wouldn't have the phone like hooked up to your you know surround sound system. That'd be
Yeah.
that's a bit much.
Well,
you
you'll
know,
be surprised what some people go
I mean,
how much how many extents they go to pull that off.
true, but the majority of people wouldn't have necessarily a surround sound system for their
No,
phone.
I would see it more
So,
like instead of like what kind of sound it has, more like what kind of sound quality it handles, like how compressed it is, or is it compressed at all?
indeed. I
Like in a
mean,
phone, it would definitely be like heavily compressed in order
yeah,
for it to
because
work. Or on
because
PC, not really.
you want to save as much memory as you possibly can when you're trying to put things
In
on.
that case, yeah, that
So,
this makes more sense.
yeah. So, so obviously there's things that you know needs to be done you know based off of the platform. So it makes sense. So, okay, and I think this is the last section. Yep,
Yep, it's the last one.
debugging and profiling. The Unreal Audio Engine is fully integrated with the rest of the Unreal Engine 4 and so benefits from all other existing profiling tools in Unreal Engine 4 used to analyze CPU usage and memory. Hooks into LLM or low-level memory tracking are added throughout the Unreal Audio Engine as well as the CSV CPU profiling. Furthermore, the Unreal Insights tool has access to all audio CPU usage. Okay. Um, I'm just kind of looking through it again just to make sure that it's all pretty much, you know, understandable for the most part. Not quite sure exactly what they mean by CSV per se. Um,
Not really sure.
yeah, but low level memory that makes sense.
Yeah,
Um, because obviously you don't necessarily want your audio to be, taking up, all the computer's RAM to process the audio, right? Because obviously if you're having all these audios, flooding the CPU, then you're not going to have any, that much room to handle anything else, right?
right.
You're going to be having a very laggy game based off of the number of sounds that you have. So, you know, got to be careful with that, obviously. But in addition to comprehensive CPU and memory profiling available to all Unreal Engine developers, there are a variety of debugging tools that can be used to view and analyze audio events as they happen in game. For example, to view all playing Soundwave instances, the objects that are actively generating sound, type stat soundwave in the dev console window. Okay, interesting. To view playing sound cues, type stat sound cues in the console window. And to visualize playing 3D sounds in your game, type audio 3D visualize in the console window. There is also a variety of console console variables that can be toggled to enable and disable various components of the audio engine, enable muting and soloing the sounds, and so on. See F audio device for more information on debugging. So, okay. Sounds pretty straightforward to me.
Yeah.
So, obviously, they have that, additional um, link there, which I'm not seeing where I'm not really seeing it in the audio section, but
No.
when I open it up, it's showing a lot of functions that are like available in Unreal, I guess, and descriptions of it. So it's very much similar to the um, audio console commands from the looks of it.
Yeah.
So, but obviously, if it's good for debugging, then we'll probably have to kind of go back to it at some point in time, I would imagine. So we'll see. Maybe.
Maybe.
Alright, but I think that's going to be it for today, there, my friend. We're coming
Yep.
up on 3 o'clock, as it is anyway. Our next session, audio mixer overview, is also going to be a fairly lengthy section, so we're probably going to be taking a couple days on that.
Yeah, it's a pretty lengthy one.
Yeah. Um, so that'll be for tomorrow, probably.
Yeah.
So,
Yeah.
um, but hey, we got through the audio engine overview at least, so there's that. Although obviously there's sections here that we were like going, what do you mean? So, and some of them were like, hey, we'll give you more information later, like the sound attenuation.
Yeah.
So more to come. So, but I mean, once we're done with these sections, then we'll be moving on to the next topic of interest. So, which let's see, let me look at our list again and make sure. What was it again that we were kind of thinking about doing next? Artificial intelligence. So, so that would be like the next section after audio that we'll be kind of looking at a little bit more.
Yeah.
So, all right, my friend.
Alright.
I think
Alright.
that's going to be it. So,
Mm,
you
I'm
go.
gonna go get something to eat, and
Exactly.
then I'll be hopping on over to Genshin.
Okay. Enjoy. Good luck.
Thank you.
Um, yeah, you got that one last um event to do.
Yeah.
Yeah.
I still have. I'm gonna be probably finishing up the event,
Yeah.
but first I probably need to finish up the world quest I started to unlocked. Farina's boss.
Right. Right.
I'll probably have to do that soon as well. So I think you got Farina, right?
Yeah.
Yep.
Yeah.
Then you'll definitely have to do that world quest to unlock that boss as well.
Probably. Probably. But I mean, um, we'll have to see on that.
Yeah.
So, but
Right.
that's for later. That's
Yeah.
that's for Sunday for me. But
Yep.
all right, my friend.
Right.
Well, you have yourself a good time, and I'll catch you tomorrow. Okay?
Yep.
All right.
Bye.
Bye. Okay, and for those of you that are still with me on this, we're going to go ahead and end it here for this Unreal study session. Hopefully you enjoyed it. Hopefully you found it informative. Again, there's parts of the video or there's parts of this where we're like going, wait, what? So if there's anybody that has strong knowledge about the Unreal Audio or the Unreal Engine audio, um, then feel free to speak up and kind of give us a little bit more clarity on that. Obviously, if we need to, we'll go and check out like maybe some other um, some other channels with their descriptions of audio if we need to. Um, because there might be points where we're like, okay, we're gonna need to know how to go about doing this, and everybody's saying we have to use this or something along those lines. So we're probably gonna need to um, look further if necessary. Um, but again, if anybody wants to, please feel free to put some comments down, some constructive criticism. Let us know um, what we might be missing, and therefore, might help out someone else, you know, that's also looking at the video. Um, so we welcome the feedback. So, but that's it. We're gonna go ahead and close it down for tonight. So thank you very much for watching. I appreciate it. Hopefully I catch you next time. And until then, take care. Have a good night. Stay healthy. Stay safe. And I'll catch you strangers next time.